I won't be in school for this lesson. I had to schedule an appointment and take a sick day. But I'm going to record this as if it is for school, just in case the substitute wants to use it, or if you want to use it at home with the packet that's provided. So this is our second probability day, and it's said the lesson is called Finding Probability Practice. So the first part is our warm-up. So for the warm-up, you have this question. In the Mega Millions lottery, the gold Mega Ball can be any number from 1 to 46. If the Mega Ball number on your ticket matches the number picked in that drawing, your ticket is worth $2. If you buy one Mega Millions ticket, what is the probability that your Mega Ball number will match the one from the drawing? Go ahead and pause the video to give yourself time to solve this. When you're ready to go over the answer, there's some unnecessary information in this problem. We don't really need to know that if your ticket matches, it's worth $2. That $2 is an extra number that can be confusing, so we can just go ahead and ignore the $2. The important numbers here are that we can get any number from 1 to 46. So we're hoping to match the number that's drawn from 1 to 46. So if you get one ticket, that's one number out of the 46. So the chance that your ticket will match is a 1 out of 46 chance. So that is what we would put as our probability. There is a 1 out of 46 chance. Just that the Mega Ball will match. Our objective today is that we will practice finding probability for simple experiments and outcomes. We have our warm-up and welcome and attendance. If you have homework, you're not going to turn it into the substitute. You'll wait until I come back. Then we have some practice work, mostly worksheet work. Whether you work individually or in pairs depends on what the substitute determines based on your behavior. And then 5 minutes at the end to wrap up and clean up. This is the first part of the worksheet. As a reminder, to find probability, you make a fraction. The denominator, or the bottom of the fraction, is the total number of options in the experiment. The numerator, the top, is the number of ways you can get the outcome or event you're looking for. So, for example, if there's a class that has 11 boys and 19 girls, there are 30 total students, so there are 30 different options for randomly picking a student. That's the total, the denominator. For the outcome of picking a boy, there are 11 different boys you could pick, so that's 11 boys out of the 30 total students, 11 over 30. That's the probability. So you have some simple practice here. The first question is, 1. There are 5 white balls, 8 red balls, 7 yellow balls, and 4 green balls in a container. A ball is chosen at random. Go ahead and pause the video so that you can complete this on your own, but we will check it together after you've had a few minutes to work on it. When you're ready to go over this, we have the 6 specific questions dealing with our problem of 5 white balls, 8 red balls, 7 yellow balls, and 4 green balls. A says, what is the probability of choosing red? Well, first we need to know the total number of options so that we can get the denominator of our fraction. So we have 5, 8, 7, and 4. So when I add that, 5 plus 8 is 13, plus 7 is 20, plus 4 is 24. So our total is 24. The probability of choosing red, well, there are 8 red balls out of 24 total balls, so 8 out of 24. It is not required to simplify, but if you did simplify, then you would get 8 divided by 8 is 1, and 24 divided by 8 is 3, 1/3. Okay, so 1/3 of the balls are red. So if you draw 3 times, theoretically, you should get red at least once. B, what is the probability of choosing green? There are 4 green balls, 4 out of 24. Again, you do not have to simplify, but if you do, you should get 1 out of 6. C, what is the probability of choosing either red or white? Well, there are 8 red and 5 white, and 8 and 5 makes 13, so that's 13 out of 24. D, what is the probability of choosing neither white nor green? So not white, not green. So if we take out the green and white, that leaves red and yellow. 8 and 7 makes 15. 15 out of 24. Again, you don't have to simplify. If you did, you'd divide by 3 and you'd get 5 out of 8. E, what is the probability of choosing a color that is not yellow? So there's 7 yellow balls. So 24 take away the 7 yellow balls is going to give me 17. 17 out of 24. And what is the probability of choosing black? Well, there are no black balls, so I'm going to say none, 0, or impossible. The second part, identify each event as impossible, unlikely, equally likely, likely, or certain to happen. So just for one example, in selecting a white ball from a box with 5 white balls, 8 red balls, and 10 yellow balls, you're comparing the likelihood of choosing the white ball to the likelihood of choosing any of the other options. And you'd say, is it unlikely compared to the other options? Is it impossible? Is it equally likely as the other options? Is it more likely than the other options, or is it definitely going to happen? So go ahead and pause the video. Okay, if you're ready to go over it. A, if we're selecting a white ball from a box that has 5 white, 8 red, and 10 yellow balls, 5 is the least amount. So it's unlikely that you'll choose a white ball compared to the other colors. B, selecting a black card from a suit of cards. This is supposed to say deck. Typo. So if you have a deck of cards, then there are 2 options. There's black and there's red. And if it's a normal deck, they're half black and half red. So it's equally likely that you will draw a black card as that you would draw a red card, which is the only other option in a normal deck of cards. C, rolling an even number on a 6-sided die. Well, there are 6 numbers, and if it's a normal die, then they're half even and half odd, so again, equally likely. D, selecting a red marble from a box filled with 12 red marbles. So the only color available is red, so it's certain to happen. You can't draw out purple if there's no purple. E, selecting a red marble from a box filled with 12 white marbles. Well, there is no red, so I'm going to go with impossible. That I was originally going to be a W for some reason. Impossible. F, selecting a boy for a field trip from a class of 35 students with 12 girls. So it's 12 girls, the others have to be boys. I know that 12 is less than half of 35, so I know that it's more likely to choose a boy. But I could also do the math and do 35 minus 12 and get 23. 23 boys is definitely more than 12 girls, more likely. 3, a day is chosen from the week. Find the probability of. Pause it. When you're ready to go over these questions. A, there's 7 days in a week, so if you choose Wednesday, that's 1 out of the 7 days, so 1 out of 7 probability. If you choose a day with the first letter S, well, that's only Saturday and Sunday, that's 2 out of the 7. If you choose a day that starts with T, that's Tuesday and Thursday, 2 out of 7. If you choose a day from the weekend, that's the same as this one. They're literally the same days, Saturday and Sunday. Unless you count Friday as a part of the weekend, and if you include Friday, then you would get 3 out of 7, and it depends on who you talk to. If you talk to a waitress, then Friday is included in the weekend. Alright, the probability of choosing Sunday is 1 out of 7. There's only 1 Sunday per week, unfortunately. And F, choosing a day with 6 letters in its name. Well, if I were to write out my days of the week, I would get Monday has 6 letters. Tuesday has 7 letters. Wednesday has more than 6 letters. So does Thursday. Friday, though. Friday has 6 letters. Saturday has more. And Sunday has 6 letters. So it's 3 of them. 3 out of 7. Okay, and on the next page there are some puzzles, and I'm just going to show you how to do them. I'm not going to give you the answers, and you'll see why in a second. First one, this is the riddle. Why did the king's birthday celebration last so long? It says, do each exercise and find your answer in the code key. Notice the letter underneath it. Write this letter in the box containing the exercise number. So this is a self-checking worksheet, and the reason I say that is because when you solve all of the problems, it should give you the answer to the riddle. And if you don't get an answer that makes sense, then you need to check your work. So that's why it's called self-checking. So let's take a look at part 1. Find each probability if you spin the spinner once. So this is a spinner with 5 equal sections. So the probability of any one given piece should be 1/5. So the probability of landing on red would be 1/5. And the probability of landing on green would be 1/5. The probability of landing on blue or white, well, there's 1 blue, 2 of them together, so 2 out of 5. Probability of landing on not yellow, well, that's anything that's not yellow, so that'd be the 4 other pieces. That's 4 out of 5. Those are the only ones I'm going to give you as example solutions, and I only gave you that many so that we can use our code key to see how we put the answers in. So we see that 1 and 2 are both 1/5, and 1/5 is the letter T. So for 1 and 2, down at the bottom, I'm going to just scooch this up so we can see the bottom. That means that for 1 and 2, I'm going to put 1/5 as T. I'm going to put T. 1 and 2 is down here. And then for 3, we see 2/5. 2/5 is S, so I'm going to find 3 and put an S. And for 4, we have 4/5, so I'm going to find 4/5 I, and I'm going to find 4 and put I. And you would continue on with the others to solve this riddle. And again, if you get an answer that makes sense, you did it correctly. If you get an answer that does not make sense, then something went wrong and you should check your work. When you finish with this riddle, I do have instructions for the other riddle, but you might not have time to get to them, and that's fine. The next riddle, when the boy tire maker married the girl tire maker, what did everyone say? Do each exercise and find your answer at the bottom of the page. Write the letter of the exercise in the box above the answer. So for number 1, suppose you roll a regular 6-faced die. How many equally likely outcomes are there? So this goes with letter A. How many equally likely outcomes are there? So 6, because there's 6 sides and they all are different. So there's 6 equally likely outcomes. So I would find at the bottom six. There's the 6. And above the 6, which was my answer, I would write A. So you find the answer down here and then put the letter that goes with it. One more, if you roll the die once, what is the probability of rolling a 3? Well, there's 1 3 out of 6 options. So 1/6 goes with E, 1/6 goes with E, and so on and so forth for the other questions on this sheet. Okay, after this, your homework is to choose one side of the page to complete. This side is more questions that just have you find a probability. The other side is another puzzle, so you choose whether you'd rather do a puzzle or answer questions. The puzzle is a little more challenging, I think. So I'm just going to give you a quick example of how to solve this type of puzzle in case you decide to do this one for homework. It says, which Italian insects often fall in love? Find each correct answer in the set of answers under the exercise and cross out the letter above it. So your answer will be whatever's left over when you're done crossing out letters. So each time you spin the spinner, how many equally likely outcomes are there? Well, there's 10 spaces. So I would say 10. And I would go down here and I'd cross out 10, the E over the 10. Find each probability if you spin the spinner once. So if I spin the spinner once and I want to see how many chances there are to get an even number. Well, there's 1, 2, 3, 4 even numbers. 4 out of 10. Do I see 4 out of 10 down here? No. That doesn't mean it's not correct. It means it needs to be simplified. Simplifying is not always useful for this, but we're going to go ahead and simplify for this worksheet. So they're both even, so I can divide by 2. 4 divided by 2 is 2, and 10 divided by 2 is 5. So 2/5, and I do have a 2/5, so I cross that out. And so on and so forth until you get them all crossed out, and whatever's left over is the answer to the riddle. And that's all for this lesson.